Welcome back to the channel again. So as promised in the previous video, I'm here with another new video that I'm going to derive Euler-Buckling expression for the critical load when the columns are fixed end. So this is the case where the columns are subjected to axial compressive load and the ends are fixed. So just to give you how it basically look like. So let's say this is one end which is said to be B, and then the other end is slightly different representation. So this is the applied load PCR. So due to the application of the force PCR, you will be able to see the deflected shape. Now the reason for representing the top end A is kind of two hinge support is because we restrict the rotation here, because for the fixed end support, it basically resists the movement. So this is a typical representation. Now let us consider the total length of this column as L, and at some at some distance x from top end, we have a magnitude of deflection, let's say is B. Now if you want to find out the free body diagram while cutting a section X, so we have so this is the initial shape, and then this is the curve shape at some distance x. So this is the magnitude of V. Now the load PCR is exactly acting at the centroid, um, and then due to the fixed support at A, we have MF, which is a fixed moment, and then at the bottom here we have a reaction moment, which is M. Now this anticlockwise moment is generated in order to keep the body in the equilibrium position, right? So this is the free body diagram when we cut the section at some distance x. So this is at a distance of x. So we know that moment about x is equal to 0. So minus PCR, force, perpendicular distance is p. So since it is anticlockwise, so this is clockwise is positive, anticlockwise is negative. Now the positive fixed end moment, which is clockwise, and then we have negative moment m here. So this becomes 0. So this can be written as m is equal to mf minus pcr dot v. Now from the moment curvature relationship, moment curvature relation, we have m by ei is equal to d square v by dx square, right? So let's say this is equation 1. Now substitute, this is equation 2. So substitute the value of m on equation 2. So what we get? So on my left hand side, d square p by dx square. So m, it is mf by ei minus pcr dot p divided by ei. So this can be written as d square b by dx square plus pcr b by ei is equal to mf by ei. So we name it as equation 3. Now this equation 3 is a non-homogeneous second order equation, right? Non-homogeneous, it's because the right hand side of equation 3 is not equal to 0. Now to get the general solution of equation 3, we need two different kind of solutions. That is complementary solution plus particular solution, right? So the general solution here for second order differential equation is sum of complementary solution plus particular solution. Now to derive the complementary solution, what we do on the right hand side of equation 3, d square b by dx square plus bcr b by ei is equal to 0. So we convert equation 3 as a homogeneous equation. So turn it into homogeneous equation. Now the auxiliary equation can be derived from this expression. I name it as 4. So auxiliary form of equation 4 is r square plus bcr by ei is equal to 0. Now the roots of r is equal to plus minus bcr by ei square root and imaginary term I. So this is in the form of a plus ib, right? So due to the repetitive nature of roots and a is equal to 0, the solution b e to the power ax c1 cos rx plus c2 sin rx. Now this can further written as just c1 cos rx plus c2 sin rx, because e to the power ax is 1 when a is equal to 0, right? Now we got the expression for the complementary solution. So we name it as equation 5. Then we need the complementary solution. To find out the complementary solution, let's say let yp is equal to x square plus bx plus c is in a format of second order differential equation. Yp dot, which is derivative of y with respect to x. So we have 2ax plus b. The second derivative is 2a, right? So I will just say that yp tab is equal to dy by dx and yp double dash equal to d square y by dx square. Now substituting this value of yp double dash, yp dash and yp in equation 4, right? We'll substitute the values of yp, yp dash, yp double dash in equation 4. We have yp double dash in equation 4 is 2a plus we have PCR V, which is yp, that is x square plus bx plus c is equal to mf by ei. So this is basically after substituting the values in equation 3.